me through that process. How did you get that?
I really just grabbed the first one and the last one.
Okay.
And saw where the intersection.
Okay. And then, did this one work?
Yeah.
It was located in the second quadrant. And then, how do you know about this one?
I multiplied negative 27.
So negative 21 would be greater than negative 25 on a number line. So that would also work. So this was your correct answer. So if you got that, good job. I know some of you were on the right track, but just didn't get there yet. Escape. There we go. All right. So everyone should have these notes in front of them. Last class we talked about how to solve system of equations by graphing. Today we're going to talk about one of the algebraic ways to solve a system of equations. We're going to go through a few and then any problems you want to go over, and then you'll have time to practice. So I'm going to start off showing this. You can take down these notes. The substitution method is a method of solving a system of equations by substituting equations within one another. Go ahead. The steps to solve using the substitution method is 1, solve one of the equations for x or y, doesn't matter which one, if it's not already. Then we're going to substitute that expression into the other equation and solve for a variable. After we solve for that variable, we'll get an answer. We're going to take that answer for that variable and substitute it back into one of the other equations and solve for the other variable. So it's a lot of solving, substituting, solving, substituting, solving. So moving. Anyone still need this? Okay. Let's do some of these problems, starting with number 1. First, you need to get in the process or get in the habit of asking yourself, do one of these equations, or is one of these equations, are one of these equations solve for y or x already? Yes. This is solved for y, both of them are, so we don't have to do step 1, it's already solved for us. Then we're going to substitute one of the expressions into the other. So we have a choice for this one. We can either take this expression and put it in for y of the other equation, or take this expression and put it into the y of the first equation. Yeah. Which one you choose doesn't really matter, because no matter what, you're going to have this equals this. Because I took one expression, substituted it into the other equation where y was, so now they are equal to each other. then it's an equation we can solve. So from way back when, at the beginning of the year, when we talked about these type of problems, get all your variables to one side, all your constants to the other. How you do that doesn't really matter. And solve for x. Questions so far? So that's part of it. But then we have to take that x and put it back into one of these equations to find our y value. Doesn't matter which one you put in. It just has to be one of them. So let's say I use the first one. Instead of x, I'm going to put in -2. And then solve for y. So our y would be -9. And then, as we talked about last class, our solutions, there's one, none, infinitely many. So here we have an x and a y, so we're going to write those together in an ordered pair. -2, -9. I would say box in that answer so I know that's your final answer. Questions on that process? Have you got that answer? Anything like that? So there will be some problems that you see like this. Majority of the problems you see for this will be more like 2, 3, and so on and so forth. But you will see some of those, so you'll need to know how to do them. We're going to skip 2, move on to 3. Is there an equation that's already solved for x or y? Yes, this one. Doesn't matter that the second one's not, disregard that. So we're going to take that expression from y, we're going to put it into y of the second equation. We're substituting it. So we're going to rewrite this second equation with this inside of it. So it will look like this. 3x plus 8 times x plus 9 equals -5. From there, we're going to distribute and solve, or combine like terms and solve. So we would combine our like terms. And then solve for x. Moving 72 to the other side. And then dividing so that x equals what? -7. But again, that's just part of it. We still have to go back and find y. So for this, I'm going to take this -7 and put it back into the original equation where x is. You don't have to draw the arrow, but if it helps you see where does this go, you can do that. So y equals -7 plus 9. So y equals 2. So what would our final answer be? -7, 2. Once you get the hang of it, it's not so bad. It's just repeating a lot of the same work. Do you have any questions so far? We're going to do number 4. Do we have an equation that solves for x or y already? Yes. The x now. This is where it gets a little confusing because we already have the x equation. We're going to put it into x instead of y, so we have to remember to keep those straight. I'm going to take this expression and I'm going to put it in for x in the other equation, not y. So it'll look like 2 times 4y plus 7 minus 6y equals 12. You'll know if you did this incorrectly because you'll have 2 variables still. You should only have 1 once you substituted. And then we can start to solve. Distribute. Start solving for y by combining your like terms. Get y by itself. By subtracting and dividing. Then we have to find x. Take that y value, put it back into the original equation where y is, solve for x. Yeah. So then our ordered pair, be careful here because we solve for y first, not x, but it still needs to be xy. So our answer would be what? 3, -1. 3, -1. Questions so far? Once you have this written down, go ahead and turn this over. We're going to do number 5. So Jude, make sure you're writing this down. Now in 5, we don't have an equation that is solved for x or y. So we're going to choose one of these variables to solve and get the equation solved for x or for y. You could choose any of these, but the easiest one would be the one where your variable is by itself, or maybe it's like -y. If it has a number in front, you could still do it with that one, but you'll end up with a bunch of fractions, so it could become harder. So I'm going to rewrite this equation down here. And we want to get y by itself by moving the x term away from it. So we're going to subtract 2x to the other side. So now we have an equation where y is by itself. And then the rest of the process is the same. Take this equation, put it into the other equation, or this expression, equation, whatever, where y is, and rewrite it. So 5x plus 3 times -2x minus 2 equals -8. And then start to solve. 5x minus 6x minus 6 would become negative x minus 6. So we would add 6. And do what to get x by itself?
Divide by -1.
So x equals positive 2. You really have choices for this when you go to put that back in. You can put this 2 back in either of these equations where x is, or in the one you solved. The one you solved is probably the easier of the 3, but you have choices. So you would solve that, figure out where your y value is, and then write your answer. 2, negative 6. Questions on that one? Any of that process?
How did you get negative x for the other?
Here, because we're subtracting these two. 5 minus 6 would give us a negative 1. So there's a 1 here, but I just didn't matter.
Oh.
Any other questions? We're going to do one more, and then any others you guys want to see, go over, have questions about. 7. Let's do 7. So the process starts out the same. Find a variable that is by itself. So which variable would we solve for? X in the first equation. I'm going to rewrite that down here. And how would we get x by itself? Minus 5, 1. To the other side. And then what would we do with that afterwards? Plug it into the other one where? For x? Yes, for x. So 3 times 4 minus 5y plus 15y equals negative 1. And then start to solve. So 12 minus 15y plus 15y equals negative 1. And then we would combine our like terms. What happens when we do that? Say that again. When you add these together, negative 15 plus 15. You get 0. You get 0. They completely cancel each other out. And you're left with just the numbers. Is this a true statement? 12 equals negative 1? No. So of our 3 types of solutions, 1, none, infinitely many, which type would this be? None. Similar to your infinitely many, if it is either of those, you will know real early on that it's no solution or infinitely many because your variables will go away. Do you have any questions on that one? Right. Look at the rest of this page, the one we skipped over, the very last page. Find any questions you want to see, go over, have questions about, not sure where to start, anything like that. To the very first one? Okay. So I'll circle them for now and then we'll go through. Which page? This. Any others?
I'm sitting because I need to take
If not, we'll do those two. If we have questions about anything else, we'll come back. So let's start with 2 on the very first page that we started on. Then we'll go to 9 on the next page. And then if no other questions, you'll have time to practice. So we have an equation that is a y, or that is equal to y. So we're going to take that equation, put it in for y of the second, and rewrite.
So basically, whatever it goes through like y or x, that's where you're putting it in the second equation.
Yes. Always. Not opposite. Now, what is opposite is if you start with y, you put in for y, you end up with x. That part is opposite, but everything else is you put in that same variable. So multiply the 3 and the 6. Combine your like terms. And solve for x. And then we're going to take that x value and put it in for y. Put it in for x in the y equation is what I'm going to say. So then our answer would be -1, -6. Did you do the task already? I mean, I do, but I'm not supposed to use them. Questions on that one? No, I purposely don't watch my own videos because my voice is, I don't know how you guys listen to it. Okay. For 9, same thing. Get one of the variables by itself. Y would be that variable. So we're going to move 2x to the other side. Take that equation, put it into y for the other one. So 6x plus 3 times -2x plus 18 equals 54. And then start to solve. What happens here? They cancel again. And you're left with 54 equals 54, which would be what type of solution? Say that again. Not no, because this is a true statement. The other type. Anthony. Evidently many. So one solution is the only time you'll actually solve everything. Any other questions we want to see, go over, have questions about before I let you practice? Okay, so there are 3 different things you can be practicing on. 1 is the rest of the problems in these notes. Go through those, practice those. Let me know if you have any questions, want me to check over anything, things like that. 2, you have 1 Khan Academy on this that is also due next Friday with the 2 from last class. So you could be getting that done out of the way so you don't have to worry about it next week. And then 3 is a partner activity, so you need someone else to do it with you. But it is a graphing / substitution practice, so you're practicing both things at the same time. So if you and your partner want to practice that, come see me and I'll get that for you. Make sure you are practicing something. Let me know if you need my help.